Today we're going to talk about standard deviation. Standard deviation is a description of how spread out data is. So our standard deviation, standard means average and deviation means difference. And so our standard deviation is going to be an average distance from the mean. So we're going to look at all of our data values and see how far away they are from the mean and come up with a number to describe how spread out data is. Your graphing calculator will find the standard deviation for you. So you don't have to necessarily calculate it by hand on your papers, on paper 1 and paper 2. You may want to calculate it by hand, but wouldn't be required on your IA. But it's good to still know where this number comes from. So our standard deviation is the average difference or distance from the mean. The way this is calculated, S sub n, standard deviation, is square root, this is just going to be some fancy notation. I'll explain it in just a second. So this is your term, take away the mean and square it, and this is the sum of all of them. So you have a whole bunch of data values. You find the difference between them and the mean and square each term, add them all together. This means sum, or add them all together, divided by the number of terms, and then you take the square root of that final answer, and this value is the standard deviation. So that's all great, but what we want to know is, okay, how do we actually do this? So just to break this down, the x sub I minus x bar squared is the difference of each term with the mean, then squared. This fancy E thing means the sum, and then we divide by n, which is the number of terms or the number of data values. Let's try this out. This is only a good measure if our data is non-skewed. So if you have a number that's very, very different from the mean, it's skewed to one direction, then this is not going to be a great measure of dispersion. Okay, so it does need to be fairly symmetric. So remember, skewed would be something like that, right, with a long tail, or it could have a long tail this way and then a short one that way. Okay, that's what skewed data looks like. And so we need to have something that's very symmetric. Okay, so good for using standard deviation. These ones would be not so good. All right, let's look at an example. A teacher gives the same test to 5 different groups of students. So in class 1, every student scores a 7. Okay. Class 2, we get a variety of scores. I don't know how many points this would be out of. Maybe it was out of 10. And then class 3, they also have a variety of scores. And someone in that class got over 100%. They got an 11. What I want to know is, let's find the mean and the median, and then I want to know which of these has the highest standard deviation. So which one is most spread out? So standard deviation is going to be a description of how spread out our data is, and so which one of these is the most spread out? So we would expect that class 3, having values down at 3 and up at 11, would probably be more spread out than the others. Class 1 is not spread out at all. They all got the exact same score. So let's calculate each of our datas for these classes. So class 1 our mean, so remember how to do mean, you add up your data values. So we added up 7 plus 7 plus 7, there's 5 of them, and find that value, divided by 1, 2, 3, 4, 5 students took the test, 7. So class 1, our mean is 7. X bar is a way of describing the mean. Okay, our median is our middle number. So we'd go through and mark off low, high, and our median's the middle value. So our median is 7. For class 2, we're going to find the mean. So for the mean, you add them up. 5 plus 6 plus 7 plus 8 plus 9. 5 students took this test, so divided by 5, and our mean is 7. Our median's our middle number. They're already in order, so we mark off low, high, and our median is 7. For class 3, we find our mean. We add them up. 3 plus 5 plus 7 plus 9 plus 11. Oops, I missed that 11. 35. There's 5 students who took the test, so we had an average of, a mean or average of 7. Our median's our middle number, so mark off low, high, leaves you with a 7 in the middle, and there it is. So if you just look at the mean and median for these 3 sets of data, they're exactly the same. This data looks exactly the same, but it's not exactly the same. This data is all a 7. This one it's got a little bit of spread to it, and then the bottom one is more spread than the middle one. So these are just describing, mean and median are just describing the middle number, okay, the middle of the data values. It's important to also have a description of how spread out the data is, because class 1 and class 3 are very different. So the scores for class 1 compared to the scores for class 3 tell us very different things about this class. In class 1, these students are all about the same level, where at class 3, we've got a couple students who are struggling and a couple students who are maybe exceeding expectations, and so we want to have a way of comparing those to each other. So we're going to go through and we're going to find by hand first, and then we'll go to the calculator, the standard deviation for each of these classes. So we're going to start with class 1. I'm going to make a table. If you decide to do this on your IA, then you could show the similar work. So we do score. So our scores were all 7s. So 5 7s. Then we have our deviation. So the first thing we need to do is we need to take our score and subtract the mean from it. So the first thing we're going to do is our deviation. So it's our score xi minus the mean. The mean was 7. So 7 minus 7 is 0. 7 minus 7 is 0. 7 minus 7 is 0, 0, 0. Okay? That's our score. Take away the mean. The next thing we needed to do was square that. So we're going to take this xi minus x bar and square it. 0 squared is 0. So now we've done this piece. We found the difference and squared them. Now we add them all up. We do the sum. 0. So that's the entire top of this. So our standard deviation, S sub n, the top is 0. N is the number of data items, and there were 5. 0 over 5 is 0. Square root of that is 0. So our first class has a standard deviation of 0. There is 0 deviation from the mean on class 1. The mean is 7. There is no deviation. There's no change. Let's do the same thing for class 2, and then I'll show you how to get this on a graphing calculator. It's good to know where it comes from, though, so we have an idea of what does this actually mean, standard deviation. So class 2, I'm going to start by listing my scores or my data values. For class 2, our data was 5, 6, 7, 8, and 9. The first thing we need to do is find the difference from the mean. So we take our data value minus the mean. Our mean was 7. So 5 minus 7 is negative 2. 6 minus 7 is negative 1. 7 minus 7 is 0. 8 minus 7 is 1. And 9 minus 7 is 2. These are the distances that each of these values is from the mean. So 5 is 2 smaller than the mean. 6 is 1 smaller than the mean. 9 is 2 bigger than the mean. Now we take that last number that we found here and square it. So negative 2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and we add them up. 4, 5, 6, 6 plus 4 is 10. So our standard deviation for class 2 is the square root of 10 over, and we've got 5 total data items, which is the square root of 2. 10 over 5 is 2. Square root of 2 is that, 1.41. So our first class had a standard deviation of 0. Our next class has a standard deviation of 1.41. That means that the data in class 1 was closer to the mean, and the data in class 2 was more spread out. So closer to the mean, more spread out. So what would we expect for class 3? So class 3's values went as small as 3 and as big as 11. So they're more varied than the other two groups. So we would expect our standard deviation to show more variance. So we should expect it to be bigger. So let's see. I'm going to show you how to calculate this using your calculator. So you'll want to follow these steps with me. Pressing the buttons kind of along with us will help you kind of follow along as we go here. So we've done this kind of thing before. I'm going to do this for, actually we'll do it for class 2 to show that you get that value with your calculator, and then we'll do it for class 3. So for class 2, this was our data. So we're going to go to stat. We need to put that data in. So stat edit allows you to input your data. So I have something else in here. So I'm going to delete it all out. Okay. So now all my lists are clear. So for list 1, 5, 6, 7, 8, and 9. If you had a frequency, then that goes in the next column. But these are each only there one time. Okay. So now we're going to press stat again, calculate, 1 variable statistics, enter. My list we put in list 1. We do not have a frequency list because each score only occurs one time. So we leave that blank and we calculate. So what number do we need to pick out for our standard deviation? X bar is the mean. This is the sum of all the values, the sum of all the values squared. These won't be very useful. The ones that are useful from this chart, just as a reminder, X bar is 7. This is the mean. Okay. The next two are not useful. You can see the 1.41 shows up here. So this is the standard deviation. N equals 5 is the number of terms or data values. What else is useful? Minimum and maximum can be useful, and then your quarters. Okay, so this stuff right here is how you would make your box and whisker plot. So it does give you min, Q1, median, Q3, and maximum. Okay, it does give you those three things so you could make a box and whisker plot. So this number is the number that's going to indicate our standard deviation. So for class 3, let's go through and change it. Class 3's data values were 3, 5, 7, 9, and 11. So I'm going to go back to stat. I'm going to edit, change my data values to 3, 5, 7, 9, and 11. No frequency list because they all occur one time. Stat, calculate, enter. We have a list 1. We have no frequency list for this question, and we want to calculate. My mean is still 7, and this number right here is my standard deviation. So if you like to write down what we've been doing, we've been going stat, edit, input table, values. Then we press stat again. We've been doing 1 var stats. What does it ask for? Our list was L1. Frequency, we left blank. And then we calculated it and we picked this number. 2.828. So we can see that number is bigger than that number, indicating that the data from class 3 has the most deviation, the biggest standard deviation, indicating it's the most spread out. Okay, so this is how you can find this value from just a list of numbers. A lot of times our values are going to be grouped into frequency list, so I want to make sure that we can find it from a frequency list. So I'm going to write down some data here, and I'll find my notes. Write down some data, and we will find the standard deviation. So example. We're going to use data that's in classes. So I want to really make sure that we have a good grasp on how to do this from data that's in classes. So we gave a test, let's say. And the test scores have been grouped by kind of letter grade. So the lowest score fell in the category of 50 to 59, and there was frequency. 1 student that received that mark. 60 to 69, there were 3. 70 to 79, there were 6. 80 to 89, in the 80s, there were 7. And then in the 90s, there were 2. So how many people total took this test? That might be a question you might want to know. So we could add these up. So 4, 10, 17, 19 students took the test total. Okay, we don't really need to know that, but it's a good number to be able to find. So I want to use my calculator to find all of the information. So stat, edit. We want to input our information. However, we can't input 50 to 59. We have to put a specific value for the score. So whenever you have data that's in classes, when you have data and you don't quite know, okay, this one student, did they get a 50? Did they get a 59? Maybe a 55? We don't know. We have to estimate. And so as a reminder, to estimate, we use our mid-interval value. So mid-interval value. So we need to find the mid-interval value for each of these scores. To do that, we average the numbers. 50 plus 59 divided by 2. So we look for the middle number between those two, which is 54.5. So 54.5. If you do the same thing with 60 and 69 divided by 2, you should get 64.5. And the pattern continues. Between 70 and 79, you get 74.5, 84.5, 94.5. And those are the values we tell our calculator because we don't have the exact numbers, we have to estimate using mid-interval values. So stat, edit, my list 1 is the mid-interval values, 74.5, 84.5, 94.5. List 2 is going to be my frequency, 1, 3, 6, 7, 2. We want to stat, calculate one variable statistics. The reason we're using one variable statistics is we've only gathered one piece of information. So we know students score on a test. That's all we've got. So one variable. List 1, list is my list 1. That was my scores. My frequency list we put in list 2. So List 2, you can see the little, I don't know if you can see it on your screen, but L2 is here. So we do second 2, pops up in L2. That's my frequency column. Calculate, and it gives us a lot of information. So it gives us X bar 0.65. So 7, this is the mean. Okay, it's a good value to pick out. The next value of interest is this one. This gives us 10.286. So we'll round to 3. That's 3 sig figs. This is standard deviation. And then if we needed maybe median, that also comes from the table. So it says MED 74.5. This is the median. And then you could make a box and whisker plot using your min, Q1, median, Q3, and max. Okay, so if it asks for that. But this one would be asking for the standard deviation. So what could we do with that type of information? If we had scores from different, maybe this is scores from 1B, and I want to compare it to my 3B class, and so I'd gather that information. Whichever one has a bigger standard deviation indicates the data is more spread out. Smaller standard deviation indicates the data is closer together. So I could have classes that have the same or similar means, but one class might have very spread out data, and the other class might have data very close together. And so that would give me information about how each class is doing. All right, this should get you going with standard deviation. I recommend using the calculator to help you with these calculations. If any of them say in your book, calculate by hand, you do not have to do that. You can use your graphing calculator to get to the answer. All right, thanks for watching, and as always, ask me if you need a little bit of help.